Mic is on. This is my third take because the first two proper takes that I was doing, my mic cut out. So all you was seeing were my cursor just going all over the screen and no voice. So that's a little infuriating, but let's just move on. Okay. Right. This is the switch count lab 2. My name is Sophion Manga, written right here. And right now I'm going to be going over my VHDL code, seeing how I implemented my hardware, and then we'll go through my test bench and the simulation. So let's get cracking. I do apologize if you hear like a psh, like a solid noise in the background. My 3D printer is going on right now. And alright, let's get into it. So everything's mostly the same as we went over in the lab. I did make one more constant, being that one right there. Oh, and also in the lab we went A through G, and then we flipped it later in the wrapper method, I believe, but I just decided to do G through A just for ease of use. I don't know, ease of brain power, whatever. But right, I just went G through A, so my constants may look a little different, or will look a little different, and then I made another switch on constant. But right here, the actual process for the switch count is basically, I started a process using the switches port, made a integer variable named count, and then beginning set count straight to 0 straight away, and then you check the first switch, or switch 0, see if it's on or equal to 1, as the constant put it right there, switch on. And if it is, then you increment count by 1, and you do that for each of the switches, 0 through 7. Right there, there's switch 7 with the same format. If it's equal to switch on, then increment count. And then right after the last if statement, we set the signal equal to, we set the signal equal to the variable. This signal right here, and this variable right there. And then we use that signal to drag the values for the LEDs and the segments, which we went over in the lab as well. This was the only bit of it that changed. Alright, and moving on to my test bench. Right, let me go all the way up. Okay, so this is my test bench code. I need to change my comment. It's not applying all possible switch combinations, it's applying some switch combinations to apply all possible outputs and to determine the correct performance. I need to change that, sorry about that. But moving on, we don't declare any ports because it's a test bench. Add the switch count component and then make the signals as well. And then as soon as we begin to relate the signals to the ports, I keep wanting to say components for some reason, signals to the ports. I did actually run the simulation without this UUT one point because I was getting an error, and it does technically go through with the simulation. It's just that when you get into it, it's just all undefined because it doesn't know what is. But I mainly did that because this digit right here was actually a 7 when I was first trying to run it, and it kept giving me an error. And I spent like 30 minutes trying to figure it out, pulling my hair. It was so infuriating. But yeah, as soon as I figured that out, changed it back to 6, it worked perfectly. But moving on, after the UUT, you do a switch select process where you go through some switch combinations to get all the possible outputs, which are 0, 1, 2, 3, 4, 5, 6, 7, and 8. So 0 being all the switches are off or none of them are on, aka 0, 0, well, 8 zeros right there. And then we wait, and then you turn on one switch. I just did this at random, like whichever. I just changed the 0 out for 1. This one being the fourth switch. You wait for 10 nanoseconds, and then right here when you're selecting two switches, I kept the first one on, and just selected the second one. So like if you were doing it in real life, you flick one and then you just flick the other, instead of like flicking one and then flicking it off and like having two different digits or whatever. So you flick one switch on, and then you flick another switch on to have a total of 2. You wait, flick a third switch on to have a total of 3, keeping the previous values the same, or yeah, previous digits the same. Waiting, you flick another switch on, waiting, flick a fifth one on, waiting, sixth, waiting, seventh switch is on, waiting, and then finally you have all 8 switches on right here. And that is the end of the process, the switch select process, and the end of the test bench. Oh, I didn't mean to do that. But now I will go through the simulation. Sorry if I like pause every now and then. I'm actually moving the mic on my headset so that way the headset doesn't go to sleep and my mic cuts out and then I'm just a video with no voice. But right here we'll start at the beginning. Switches is 0, 0. Oops. Goodness, I don't mean to do that. There we go. Just wanted to move this out a bit. Okay. Alright, yeah. I don't even think I didn't move this one. Either way, moving on. 0, so switches is 0, 0, 0, 0, 0, 0, 0, 0, 0, 0. I think that was 8. LEDs is 0, and segments is 40, which may seem a little weird, but it's actually in hexadecimal. So each digit of hexadecimal corresponds to 4 bits of binary, or it corresponds to 4 bits of binary for these two. Since the segments is 7 bits, the first digit is like the first 3 bits, and then the second one is the last 4 bits. That tripped me up for a little while until I figured that, until I looked back and was like, oh yeah, 6 down to 0, 7 bits. Either way, the 40 is actually 1, 0, 0, 0, 0, 0, 0. So I can show you that right here. If we look at our constants and we go to 0, you can see that right there. So 1, 0, 0, the first 3 bits right there is 4, and then 0, 0, 0, 0, that's a 0. So that's why it's 40 right there. But if you look at that, this means that since the LEDs in the segment are active low, it means that A through F are on and G is off, which is what we would want when we want it to display 0, all of them being on except for the middle LED. But moving forward, switches is now 0, 8, and LEDs is 0, 1. And well, first let me explain the 0, 8. So 0, 8, if we look at our test bench, when we flick one switch on, the 0 is the first 4 bits, so that's 0 right there. And then 8 is the last 4 bits, so 1, 0, 0, 0, 0, or 1, 0, 0, 0. Well, yeah, 3 zeros. Yeah, 1, that's 8 right there. But 0, 1 is showing the LEDs. So if we go right here, scroll down to our LEDs, when we have one switch on, and we have 0, 1 in the simulation, so that's the first 4 0, and then the last 4 is right there, that's 1, so that's why it's showing 0, 1, and 79 is 1, 1, 1, 1, 0, 0, 1. So if we go over to our constants again, and we go to 1, you can see it right there. So there's our 7, 1, 1, 1, and then here is our 9, 1, 0, 0, 1. And that is why it shows 79 when we have one switch on. And right here, this is our second switch. So 48 for the switches. If we look at our second one right here, first 4 bits is 4, 0, 1, 0, 0, and then 8 is 1, 0, 0, 0. So that's how that is. And then 0, 3 is because of the LEDs, since we flicked on, or since the second LED is now on. So 0 right here, and then 3 right here. So 0, 3 for that, and then 24 corresponds to 0, 1, 0 for the 2, and then 0, 1, 0, 1, 0, 0 for the 4. I can show that right here. Go to constants, go to 2, 0, 1, 0, 2, 0, 1, 0, 0, 4. So 2 and 4, or 24, right there. And it does the same thing throughout each of the like whenever we wait 10 nanoseconds, flick a switch, wait, flick a switch, wait, and then right here I'm just going to skip to the oh my goodness, my mic had cut out, so good thing I caught that when I did. I don't know where it cut out, but I think I had just explained this one, or I think this one, but right, so 48, I'll just explain it once again just because I don't know where my mic cut out. 40, did I already go over this one? think I'd already gone over this one. I'm going to go over this one. 4A. So switches is 4A. That is the fourth value for the switches. 0, 1, like 1, 2, 3, 4 right there. So if we go over here, you look right here. This is the 4. First 4 bits is 4, 0, 1, 0, 0. And A is 10. So 1, 0, 1, 0. So that's why it's 4A. 0, 7 for the LEDs is oh, wrong area. Since we now have three switches on. It was 0 or 3 LEDs, 0, 1, 2, 3. We go over here, look right here. This is our 0 for 4 bits, and 0, 1, 1, 1 is 7. So 0, 7, 1, 3. And 0, 1, 2, 3, 0, 7, 1, 3. And segments is 30. 30 corresponds to 0, 1, 1, 0, 0, 0, 0. I can show you that right here. So we know switch count is 3. So 7 segments should be displaying 3. So if we go look at our constant, 0, 1, 1, 3, 0, 0, 0. How many times did I just say 0? Whatever. It's a 0 right there. So 3, 0, 30. That's right there. And I'm just going to skip to the last outcome now. It's the same way across all of them. I'll just explain the last one now to show you that they are all working correctly. So FF is just 1, 1, 1, 1, 1, 1, 1, 1. So all of the switches are on now. We can see that right here. F being 15. We've got 15 right there. And 15 right there. So that's all the switches on. LEDs is FF because it's in the same boat. If all the switches are on, then all the 8 switches are on, then all the 8 LEDs are on, the first 8. And then 0, 0 may seem like, oh no, these are all on and these are all off, but we have to remember that this is active low. So 0, 0 is, 0, 0, 0, 0, 0, 0, 0. 7 zeros, since segments is a 7-bit value. So if we look at that, if we go to our constants and we look at 8, it's all zeros since it's active low. So that is working correctly, and that is the end of this video, the simulation and the going over like the code. In the next video I will be showing it working on the basis board. So I'll be right back.